we've got a nice 4-mark trig question today, followed up by a 1-mark explain question, which is maybe not so nice. Let's get into it. So for part A, we're trying to prove this identity. Best thing you can do with identities is start on one side and try and work your way to the other. Usually it's going to be the left-hand side that you want to start with. So that's tan theta plus cot theta. What do we know about tan theta? That is sine over cos. What do we know about cot? It's 1 over tan, but it's also cos over sine. It probably will be possible if you do 1 over tan, but I believe writing it in terms of cos and sine is going to be much more helpful. These two fractions don't have a common denominator. Let's remedy that. We can turn this into sine squared over cos sine, and we can turn this one into cos squared over sine cos. These two denominators are now the same, so we can turn them into one fraction. Are you seeing what I'm seeing? Sine squared plus cos squared, we know that's 1. At this stage, I'd be looking back to the question and seeing if I'm heading in the right direction. The question has 2 cosec 2 theta. So there's going to be a 2 theta. There's going to be a double angle formula in here. So what I'm going to do is I'm going to times by 2, numerator and denominator. The reason is 2 sine theta cos theta is sine 2 theta. Now there's only one more step. 1 divided by sine is cosec. This is equal to the right-hand side, which is exactly what we wanted. We don't really need to focus on the information given here. That's more important for the question writers to say, well, you can't divide by 0. We don't need to really mention that in any of our proof. As for part B, let's do it up here. Multiple ways to do this. So personally, I would be drawing a diagram. I love a diagram. Tan theta plus cot theta equals 1. Why don't we use part A? We didn't do it for nothing. Like this. So 2 cosec 2 theta is equal to 1. Which means that cosec 2 theta is equal to a half. But I know what the graph of cosec 2 theta looks like. So sine, if I draw sine as a dotted line, like this, then the cosec graph will look like this. The 2 theta there means it's just squished, but I haven't put anything on the axes. So you can imagine mine is just stretched out. And where's the line y equals half? It's right here. There are no intersections. Therefore, no real solutions. And here I'm going to go through the proof of how to do it if you turned cot into 1 over tan. You can see it does work in the end, but you get some triple fractions along the way, which is not too nice. Of course, if you did this, you wouldn't lose any marks. Well, there you have it, another question complete. Try these 2 questions if you want a bit of extra practice, and I'll see you in the next one.